Yeah, so I don't know if I'm going to win the award for the longest title of the talk at the conference, but that's the title. It's from 4 hours to 8 minutes with AI agents that transform SRE incident response. Now, there's an asterisk there that says like citation needed a little bit, right? So this 4 hours to 8 minutes, I don't have actual proof to show you that. However, how many of you have used AI or AI agents in your work? All right, so I'm assuming everyone has seen the amount of efficiency and how much more efficient one can get. So let's just agree that, let's say 4 hours to 8 minutes is more or less somewhere there. Like I've been using it for code, and I'm not a web developer, but I've done websites and web applications, and something that would typically take me a day, it took me like an hour to do. So I think it's fairly safe to say there's a lot of good efficiency there. All right, so what I'll talk about today is, here's the agenda. I'll talk briefly about the incident problem, just to set up the stage for everything. Then I'll move into the AI reliability framework and explain briefly what that is. And then we'll talk about the basics of AI agents, and I'll do a demo. So I originally, when I submitted this talk, it was based on I want to say 4 or 5 hour live stream that I did with a colleague, where we actually built a couple of agents. We used K-agent, right, and all that. And I could have just given you those agents and like, there you go and run them, right? But I figured, I think it's more useful for everyone to understand what are the basic building blocks, how they work together. And that's what I'll do with explaining the basics, but also in the demo, if the demo gods are on my side today. I'll try to build up a couple of agents or an agent with a couple of functionality just so you can get a feel for how this works and how you can go and build your own. It's almost like, to me, it almost feels like it's learning how to Google. You know, like you have to know how to write a query to get good results. All right, so incident and automation problem. So the problem here is like you're troubleshooting issues for hours, you're using outdated docs, you're context switching between logs here, logs there, your customers can log in, and basically everyone is stressed, right? Now, in reality, what you want to do is you want to fix the actual problem. You want to get to a point where you have enough information, you have enough context to actually fix the problem, the actual incident, and resolve it, not necessarily waste time by going through the runbooks, figuring out the documentation, sifting through logs, going through Slack messages, and so on. Now imagine what if AI or AI agents could handle all that boring work, right? What if AI agents could gather all the data for you, they can suggest what some of the root causes might be, they can do the pre-investigation for you, and basically help you get to the solution and resolution faster. Now you could also push this a little bit further and say, well, what if the agents are so advanced that they can actually detect patterns and figure out that something might happen in like an hour or so and basically alert you on that, right? Similar with things with like automation, with scripts and runbooks, all those are brittle, right? You change the config, you update an API somewhere or an endpoint, naming convention, change something, and everything breaks, right? So third thing is the knowledge gap. So I'm pretty sure a lot of you have, or maybe even are experts in your teams. Expert might know the fix. They might know it because they went through it a couple of times, but guess what? They're on vacation and it's 3 a.m. They're not there. You'll have to go and figure it out and solve it for yourself. Right. So traditional automation works basically on if this happens, do this, right? So there's some rigid steps. The AI reliability engineering is more of a, we want to achieve a certain outcome. So it's more adaptive and it's more context aware, right? So it's context, learning, and adaptation. All right, so what is AI reliability engineering? It's basically a way of enhancing software reliability by embedding these context-aware and smart AI agents into your existing engineering workflows, right? So the idea is that you would connect your, and just make the slides bigger here so I can see them. The idea that you could connect your AI agents through your systems, through MCP. So anyone heard of MCP? Okay, a couple of people. All right, so I'll later explain what MCP is, right? But it's basically a way of giving your agents access to internal APIs, external APIs, data, logs, monitoring, documentation, runbooks, and so on. So these agents can then basically figure out and gather all the context that they need. Now, one caveat for this whole presentation here is that I'm not thinking about AI agents as replacements for humans or for human judgment. I'm thinking of them more as an additional tool in your tool belt that you can use to, it'll make you basically more efficient, right? Just like any other tools that you have, right? AI agents, I would look at them from that lens instead of something that will replace you or replace me at some point. Hopefully that doesn't happen. All right, so how does an agent look like? So there's, at a high level, there's 3 building blocks to an agent. First one is system prompt or instructions. So system prompt is text-based. It's a natural language explanation of what you want your agent to do. It's an instruction to an agent. Imagine if you have a junior employee and you want them to do a specific task. You would tell them, you're not going to go and tell them, hey, do X, right? You'll tell them, hey, I want you to do X, but here are the specific steps maybe I want you to take, do this, check that, like figure this out. Similar with agents. Like they're, in a way, they're very smart, but they need a lot of direction. They know everything, but you have to point them at things, and you have to give them some sort of guardrails and some sort of box where they can play inside and give them the direction and instructions on what to do. So that's the first ingredient. Second ingredient are the tools, right? Tools and then LLM, large language model. Now, large language models do not have access to external APIs, external tools. They're basically bound to a specific training set. Now, when I was working on the slides, I was thinking of giving an example on how this works, and then basically, stuff is moving very fast. So last year, if you would go to Claude or if you'd go to OpenAI and you would ask a question like, what's the weather like today in Dublin? It would typically tell you that, oh, sorry, like my cutoff date for training data is October 2023 or whatever it is. I cannot answer that question, right? Today, those chatbots, OpenAI, Claude, are already agents in their own. So if you do that today, I'm pretty sure they'll go and actually fetch the data for you, right? But the way that they do that is through accessing these tools, right? So these tools, they allow agents to interact with Kubernetes API, to fetch websites, to get the documentation, to access GitHub, Prometheus, whatever you want, right? The tools are implemented either in your AI agent application. It can be an API call or a call to an MCP server. It's basically on the AI agent developer side. They're the one who decides how this works and what to call. And then, as I said, LLM basically makes decisions and creates responses. So next step is the agent loop that I want to talk about. Typically when you're talking to an LLM, let's say chatbot example, year and a half ago, right? You would send a user query, send a prompt, send a message. The LLM would calculate and do the tokens, and it will return you the response, right? So the way it works is user query, let's say, how can you help me with X? The agent takes the instructions, the system prompt. In this example, we're saying that the agent is a helpful Kubernetes agent, ... and I'll show you how some of these look like. They can be very verbose. So instructions, tools. In this case, we have get pods, get services, any other Kubernetes tools, plus the user query, right? So those 3 things are sent to the LLM. That's the context, the input to the LLM. The LLM will crunch the data, it will burn some tokens, right? And then it will return you a response, and it will say, oh yeah, I can help you with X, and here's the answer. So user query, for this example, with this model, like with the textual models, is text. The input is text, it's a string. Same with the instructions, the input is string. But what are the tools, right? So tools, and this was one of the, when I was like learning about this a year and a half, 2 years ago, whenever it was, this was kind of a shift that I had to like learn on like how does the actual tool calling work, right? So user query is a string. Instructions or system prompts, they're a string as well. Well, guess what? Tools are strings as well. It's basically, they're defined by a schema, and that schema describes what the tool does and what the input parameters are to that tool, right? So in this example, I hope it's visible enough from the back. We have a tool called getPods. There's a description that says, well, use, and this description is basically instructions to the LLM. So this description is the LLM will read that and decide when and whether to use the tool or not. So use the tool to retrieve pods from a specific namespace in a Kubernetes cluster. And then we have the input schema. In this case, we have a single argument. It's called a namespace. It's a string, and the description of that parameter is namespace name. Right? And lastly, we're saying that it is a required argument that has to be provided, right? So this definition with the user query and the instructions, it is all sent to an LLM. So let's see how this looks like. So I'm gonna read this. We're reading it from the top and from the left to the right, right? So the whole string, show me pods in the test namespace, that's the input to the agent. The instructions are your helpful agent, Kubernetes agent, etc. And then tools, get pods, description, basically this schema in this example, right? So these three things are sent over to the LLM, right? The LLM, remember, does not know and cannot call the tools for you, right? So what LLM does is based on the instructions, based on your query, based on the tools that you sent it over, it makes a decision on what to do. Typically, the simplest decision is, here's a response, right? In this case, we provided a list of tools, and our query was very specific, right? So LLM was able to figure out, oh, the user is asking me for pods in the test namespace, and I have a tool that's called getPods that will return me pods in that namespace. So what it does, it creates this special response. It creates a tool call that basically says there's an ID, right? Some ID, unique ID. It says there's a function with this specific name, and here are the arguments, the argument names and values, right? This gets sent back to the agent, to the application, and it's on agent to figure out what to do, right? So the agent basically does something like, gets the response back and says, hey, is this a final response to the user? Oh, no, it's not. Do I have any tool calls I have to do? Yes, I do, right? There's an array of tool calls. This is just one here, but could be hundreds, doesn't matter. So that gets sent back to the agent. Then the agent itself decides to, not decides, but goes and calls the tool, right? So it's the agent developer who parses these values and says, I have to call getPods, and pass in an argument namespace with the value test, right? So you can see the execution of the tool is done on the agent side, and it doesn't really matter, in a way, whether that's coming from an external API, if the agent is gonna run, or your AI application is gonna run a CLI, it's gonna call an internal, it doesn't really matter, right? It's on the agent to do that. So the agent will call the tool that LLM asked it to call. And then what it's going to do is going to take the original message, it's going to take the results of this tool call, so the list of pods, and the tools that are already defined, and send everything back to an LLM again, right? And notice left up on the left there, I have a word that says loop. So that's the agentic loop here. So what happens in this case? It gets sent back to an LLM. LLM, again, remember, it has the same context it had before, plus the results of the tool call, plus the list of tools. The LLM can then decide and say, well, based on this new context, maybe I need to run another tool, right? And it can go back and forth, right? Until there's no more tools to run, until the LLM says, okay, I'm done, there's no more tools I want you to run, and then it's gonna return the final response, and it's gonna say, hey, here are the pods in the test namespace, here's that response. Does that make sense? In a way, it's long-winded, but this was one of the things that was maybe a little bit harder to understand how it works. So LLM doesn't know how to run the tools. It merely tells the caller, hey, I want you to run this, and then give me the results, and I'll combine the response and send it back. All right, so tool calls, this is a segue into talking about MCP a little bit and what does that mean. So imagine you have an agent and you want to call Azure, you want to call AWS, GCP, Slack, GitHub, any other external or internal services that you have. From the developer standpoint, what you'll have to do is you'll have to write some code to make calls to those APIs, to parse the results, to prepare the requests, et cetera, et cetera. And it's typically not the same, right? It's like, well, it's a little bit different here. We need that API key, we need this, we need that, right? So you're gonna implement 3 separate pieces of code where you're basically calling these tools. If you have one agent, it's kind of okay, right? But then imagine if you have 2 or more agents, and those agents want to call those tools again. So you'll basically have to re-implement the same piece of code in all of your agents, which, I mean, you can do it. Who am I to tell you not to do that? But it doesn't make sense, right? Because you're duplicating code. If something changes, you'll fix it in one place, and you have to fix it in another place. It's just not, it's not very efficient, right? So this is where MCP comes in, right? So MCP stands for Model Context Protocol. And it is an open source standard for connecting agents to external systems, to any external tools. So in this case, the agents only need to implement the well-known standardized interface that MCP defines, right? So things like list tools. So there's a known way on how an agent can get all the tools from an MCP server, how to get all the prompts, how to get some like examples or whatever it is, right? It's well defined. So all the business logic of accessing a cloud provider or accessing GitHub is enclosed in that MCP server, right? That MCP server can run as a HTTP server somewhere. You can run it locally, you can run it inside Kubernetes, you can run it wherever you want, right? But it's an endpoint that exposes a well-known interface that your agents then implement, right? So if you have multiple agents, your agents only need to speak MCP. They don't have to speak Kubernetes, or they don't have to speak AWS or GitHub, right? So it's a way that you can scale out, and that's what you've seen. I think everyone's seen the explosion of MCP servers, right? They're everywhere. Everyone is doing it, right? And yesterday at our booth, I had a couple of people were asking when I was explaining the K-agent, right? I was saying, well, you can, like we have Kubernetes tools, we have Prometheus tools. Oh, but can it access PagerDuty? Can it access Datadog? I'm like, if there's an API like endpoint, you can do it, right? It doesn't matter. If there's no MCP server yet, there'll probably be one very soon because everyone is building them, right? Okay, so MCP servers, it's a collection of tools pretty much. There's also other stuff there. There's, as I said, prompts, resources, and some other things, but mostly people are using it for tools. There's also a way to authenticate through MCP. There's a standard way that you can do that, right? I think it's a fork of one of the MCP specifications where they're doing UI. So you could have, let's say, Slack in this example, right? Slack MCP server can decide to render or return a specific UI to the caller, which means if you think about a chatbot experience, right? I don't have to write UI, right? Slack knows best how to write the UI for Slack. What if they just return me the UI and I can render it to the user, right? So there's a lot of stuff happening here. It's a very fast-moving moving area, but it's very interesting. Multi-agent scenarios, a little bit on this as well. So how do agents talk to other agents? In a K-agent example, we are supporting agent-to-agent protocol. So that's protocol that was created by Google. And basically, what MCP is to agents and tools, that's what A2A is for the agent-to-agent communication, right? So it defines a specific interface, specific endpoints that an agent has to expose in order for other agents to call it. So it doesn't matter if you use Crew AI to build your agent, if you use K-agent, if you use Google's ADK, LangGraph, LangChain. As long as they expose A2A, the agents can talk between each others. How do I build and deploy agents? Has anyone built any agents? A couple of people, all right. So I kind of broken it down. Again, there's a lot of innovation happening in this. So there's like SDKs popping up daily, and there's like gazillions of them that I haven't even heard of probably, right? But a couple of big ones. So breaking it down between code and no code or declarative. Code ones, the most popular ones, Microsoft Agent Framework. So that was announced, I think, either this week or late last week. It was formerly known as Autogen and Semantic Kernel, so they merged those two projects, and they're calling it Microsoft Agent Framework. Basically allows you to write your agents, I think, in Python and TypeScript. There might be Go as well. Google has its own agent development kit. There's LangChain, LangGraph. There's Crew AI. The idea here is you're a developer, you know how to write code, you pick an SDK, you go and write your agent, you package it up in a Docker container, and you deploy it somewhere, right? Or you deploy it on their platforms. Then there's declarative. I'll talk about K-Agent. It's an open source project. K-Agent, which allows you to define your agents without writing a single line of code, just declaratively through YAML. We all love YAML, right? N8N. And there's OpenAI Agent Builder. This is very fresh as well, I think released yesterday or 2 days ago. Just a declarative and visual way to build agents. So there's a lot of stuff here. All right, so let's focus on K-Agent. So K-Agent is an open source Kubernetes native framework for building AI agents and MCP servers. It runs on Kubernetes. It is open source. It's part of CNCF. It was donated to CNCF earlier this year. It runs locally. You can bring your own models. You just bring your API key. It works with Google models, with OpenAI models, Anthropic models. You can even run local Ollama models if you want, and it works against that as well. We also ship with a collection of MCP tools, so tools for accessing Kubernetes, Prometheus, Grafana, Helm, Argo, Cilium, Istio. There's a bunch of things that it already ships with, so you can use them as a starting point. What else? We have weekly contributor and maintainer meetings, so please join us. So we are always looking forward to see new people join the community and give like a real-world experience on how they would use this, what are their scenarios. And yeah, so this brings me to demo, the most exciting thing. Let me just switch this back. All right. Perfect. That was easy. All right, so as I said, I have the prepared agents that I could just go and deploy and show you, but I'm like, yeah, let's tempt the demo gods and do something else. How's the fonts in the back? All good? Perfect. All right, I can zoom in more if you guys want to, but all right, so let's start with something very simple. So so let me show you. So I have a cluster running locally that has book info application deployed. That's a sample application that looks like this. It's just a couple of services that are running, just as an example. I have Istio installed. That's just merely because I wanted to have Prometheus and get all the data. Prometheus, Kiali, and Grafana is there as well. I have K-Agent with a bunch of agents and tools. And that's pretty much it. And that's all running locally on my laptop. So let's go to the UI. So everything that I'm doing in the UI here, you can do it through YAML as well, and I'll show you that in a little bit. So let's delete this one, because that was the first one that I wanted to show you. So this is actually a colleague like an hour ago who was playing with this, and I'm like, well, I should show this in a demo, why not, right? So this is a simple Yahoo Finance server. It's an MCP server, and I just want to show you how easy it is to get this configured in K-Agent. By the way, I have models configured as well. I have the default model, which is OpenAI, using GPT-4.1 Mini. And I have Gemini 2.5 Pro installed, right? But we support a bunch of others as well. All right, so let's create the MCP server. I have Grafana already. I have the tool server. I have the query doc. These are the ones that are deployed by default when you install KAgent, but it's all customizable. You can remove them or add your own by default if you want to. All right, so the only thing that I have to do is put in the name of the server as specified in their documentation. So we'll add this. So the server is added. And if I go back here to my terminal, and we'll say get MCP server. So MCP server and all the resources, the agent, MCP server, model, those are all CRDs in Kubernetes, which means GitOps, right? You can do that from GitHub. You can set it up like that and configure your clusters and everything with that. All right, so we have the Yahoo Finance server running. So if I go here and expand, hopefully the tools will show up. Let's do this. Yahoo Finance is here. So it creates an actual pod with the MCP server running there. Oh, it's still installing it. The Wi-Fi is maybe a little bit slow here, but all right, let's wait for this one to happen. And while this is happening, I'll show you how I can deploy a Kubernetes, how I can deploy a GitHub MCP server as well, because we'll use that one as well. So this is the URL to the GitHub MCP server. I've pre-created my token and a secret, right? I didn't want to flash it here for everyone, so let's take this, and instead of going through the UI, I'll just deploy it here. There you go, boom, so that one was created. And it already discovered all the tools that are coming from this GitHub server, which means that I can use these tools in my agents now, right? Let's see if the finance thing, oh, the finance is back as well, right? All right, so let's do a simple finance one first, and we'll call it finance agent. We're gonna deploy it in the Kubernetes KAgent namespace. I'm gonna use the declarative option, but you also have an option of if you already built your agents with ADK, LangGraph, or Crew AI, you can bring them in here as well and run them, right? So we'll do declarative. We'll just say finance agent, right? And this is where the agent instructions or the system prompt comes in. We start you with some basics, right? It says, hey, you're a helpful agent. We'll say helpful finance agent. So Yahoo Finance agent made by the KAgent team. Here are some of the instructions, right? If the question is unclear, ask the user, right? Be helpful and friendly. If you don't know the answer, do not make things up, because LLMs are known for hallucinating and making things up. And then some bits about the response format, right? We're saying always format your response as, let's say, markdown table. Well, let's see what happens, right? So we'll pick 4.1, and then we can go and give this agent some functionality. So let's do Yahoo, and we'll say price history, right? So let's do that one, create an agent. And what this one did behind the scenes, it creates a finance agent here, an actual CRD. And let me show you how this looks like. Finance agent, oh, YAML. There you go, it's still coming up, right? But it basically has the instructions that you've seen in the UI, and it has reference to the specific tool from the MCP server that we want the agent to use. So let's wait for this to come up. So it looks like it's ready. Let's refresh here. Yep, it's ready. All right. So what can I do here? So I can say, note it has access to this one tool that allows us to get the historical price for a given stock. So let's say, whoops. Let's say, what can you do? What can you do? Let's ask it, right? There you go. Notice how I had in the agent instructions, I had the line that says always format your response in Markdown, but I added in Markdown table. It figured out that, oh, maybe this is a good piece of data that would be displayed as a table, so it displayed it as a table, right? All right, so we have that. Here's what it can help you with. So let's say, show me the price history, or price history. Keep clicking this for let's do NVIDIA, right? Let's see what happens here. All right, so notice this. Oops, let me scroll here. So it's telling us that it's calling this tool. Let's go here. Get price history, right? This is the symbol. This is the arguments that are being passed in, right? And then here are the results that we get back from the tool. And then what happens is, if you remember that sequence diagram back and forth, right? Then the agent actually goes and the LLM formats the data in this case, in table format, because that's what we asked, right? So this was a simple one. Let's do so we have the Kubernetes, the GitHub one. So let me go here, and you know what? I'll just deploy this one, and we'll, let's see. There's a lot of stuff here, and I'll guide you through and show you what let's do this, right? So this is an SREcon demo agent that I pre-created. One tip, if you're building agents, sometimes the system messages can be, they're very important, right? But if you're doing a demo or something, it's easy to go to OpenAI and Claude and say, hey, I'm working on an agent, and I want the agent to be able to do A, B, C, D, E, F, G, whatever it is. Can you create a system prompt for me? So it actually went out and created the system prompt for me. I modified it a little bit, right? But basically what we're saying is you're an SREcon demo agent. You're specialized in analyzing metrics from Istio-enabled Kubernetes cluster, figuring out root causes and fixing them, right? And then after that, we're talking about what are the actual capabilities, right? You can query and analyze Prometheus metrics for these reasons. You have access to real-time metrics. Here's the Prometheus URL where you have access to historical data. I think, let's say 50% of this is too much, maybe, right? But we'll go with it. This one is very important. If you worked with Istio, you know that the metrics are called a little bit different. They're prefixed with Istio, so you always have to tell it that. Some of the labels, verify that the service actually exists. If the service does not exist, try to do a fuzzy search, find the actual thing. Always use the fully qualified service name, right? So instead of just using reviews, use reviews default or whatever the namespace name is. Here's how you analyze things, right? First, you verify that the service actually exists. Then you're gonna go and collect core metrics. Default is last 5 minutes. Request, error, response, right? And then you're gonna identify the issues based on these thresholds, right? So we're saying if error rate is higher than 5%, that's critical, right? So if there's any 500s, do this. If latency is greater than 1,000, warning if it's this, right? And then provide context, some recommendations. I also have this line in here that's basically saying automatically create a Grafana dashboard for all critical services to show the failures and failure metrics. And lastly, I have GitHub integration as well. And it's actually saying to ask the user for a repository name, but we're going to delete this because we know exactly what the repository name is. So we'll say repository. Actually, we'll leave it in, and then we'll fix it. Here's an example, right? You're basically giving it examples on how to respond, what to do. Oops. What are the what are the potential user questions and how the agent should respond, right? So it knows how to do it. And then some more configuration here, some error handling, and then remember to do this. Never guess, right? Query the Prometheus, etc. All right, so let's go here. Oops. All right, so here's the agent. I'll just click here briefly to show you the tools it has. So we gave it access to Prometheus query tool. So this allows the agent to generate a prompt QL and then execute that against Prometheus. It knows how to get resources from Kubernetes. It knows how to apply manifests. By the way, you are in charge. You, as an agent developer, are in charge of which tools the agent has access to. If you don't want your agent to be writing in your cluster, well, you're not going to give it that tool, right? Don't do that, right? Reminds me of when I was playing with some things, and like early on, we were playing with something, and we're trying to make the agent fix a specific issue. Like we had a failing deployment because it was using like an invalid image name, right? So we said, can you fix this? And back and forth and back and forth. And it turned out the last message from the agent was, there you go, it's all fixed. I deleted the deployment, right? It's like, okay. I mean, theoretically, it's fixed. It's not failing, but just a lesson. Definitely don't start with this in production, right? And then create issue, because we want to create issues in GitHub. And then I have the update dashboard. This is the function or the tool coming from the Grafana MCP. All right, so let's try this. Now let's say, show me the health of all of my services in the default namespace. Let's see what happens here. All right, so it's getting the resources, so that's good. It's getting all the services, that's good as well. It's completed. It means it got the results, now it's sending it back to an agent, so to hopefully provide me an actual response. We'll see, but it's taking too long. We'll see what happens. There you go. And now it's doing Prometheus queries, right? So it's calling this specific Prometheus URL that I specified, right? And it's doing a query here on all the services. And let me show you, I have a couple of them running in the default namespace, right? So I have book info stuff. There's a waypoint proxy from Kubernetes, and there's the Kubernetes service, right? So query, a lot of query things. And then and by the way, if you see it's pulsing here, these are the internal thoughts of an agent, right? This is what it's doing right now, it's thinking. And it was saying, I don't know if you saw, it's like, oh, I should use, seems the use of pipe character and dot, blah, 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 doesn't work. Triggered an invalid query. I'll try a safer approach, right? And now it's doing the same thing. There you go, right? And now we got the response, and it's saying, here's the health summary of all services in the default namespace for the last 5 minutes, because we said 5 minutes, right? No 500 errors, all is great, right? No error rates, everything overall very good, right? Et cetera, et cetera. Perfect, so let's break it now. So I have a stupid thing where we're gonna break the review service, and the way that I'm gonna break it is I'll just make a typo here. Very simple, and let's see how it can handle that. Let's go here, and we'll say apply. Oop, did I apply it? I didn't. Boom, so it's configured. By the way, I do have, let me go here. If you're wondering, I have the constant requests being sent to the service, so that's why it's gonna work. And you'll notice down here, it's already failing, right? It's saying fetching product reviews. So let's see if I ask the agent now, how's the health of the reviews service, and I'll say in the default namespace, just in case. Because sometimes it'll come back and say, well, what namespace is it in? So let's see what happens here. It should figure out that something's wrong, right? It's gonna do the query for the reviews. Go. We got the results. It's doing some more queries there. It's executing tools. Need like an elevator music here. All right, there you go, right? So reviews.default is experiencing warning level issues, right? I should have waited a little bit more to get critical, right? But this is all the data that it got from Prometheus, right? And figured out how many requests, how many things are failing. It was able to interpret the data that it got back from Prometheus, right? So here are some of the recommendations, right? So, and then it asks me at the end, do you want me to assist with further investigation or create a GitHub issue? So let's say, create a GitHub issue in the SREcon demo repository. Owner is Peter J. Okay, so let's have it do that. So this one is gonna go and call the create issue. Now it's asking me, you come up with the title. See if it works. I suggest, okay, yeah, create the issue, please. Sometimes it's very safe, but it's asking you the same thing over and over. I mean, not the same thing, right? It's trying to confirm everything, but this time it actually went there, right? It created an issue. There you go. And I think it should return me there you go, right? So it created an issue here. So if I go to GitHub, right? There you go, right? It's saying warning, elevated, whatever, right? And it uses the same format as it used in the response originally there. So let's see if we can make it, because it has access to apply, it has access to get resource YAML, and it has access to apply manifest. Let's see if it can fix it, but let's also see, create a Grafana dashboard for me. So let's see that one. This will call the update dashboard, and we'll create a Grafana dashboard for me for this specific thing. So forget about crafting the Grafana dashboards manually and creating them. You can just have an agent do that for you. So we'll go and do it. It'll create the thing. All right, so it said it created default namespace services held. All right, so it created something. So let's see what that is. So I go to dashboards. Default namespace services held. All right, well, that's helpful. No one saw that, but yeah. But yeah, I mean, you could, so the way that you would fix this, for example, what I would do in this case is I would create another agent that's just Grafana agent, right? And that agent will only be responsible for creating Grafana stuff and nothing else, right? So the input would be the data for the dashboard, and that's what it would go and do. All right, I have 3 minutes, so let's do this. Can you fix the issue for me? Can you fix the issue for me? Let's see. Let's see if it gets confused or not with a lot of context. So what it should do is, yeah, I'll help you fix the issue. All right, so it's getting the resources, it's listing the pods, it's figuring out the pods, it's trying to get, it won't be able to get the logs because it doesn't have access to the tool that allows it to get logs, but should be able to get the resource YAML, and it should be able to figure out what's wrong. So let's see. Oh, this would be like a perfect ending to my talk if this works. All right, so can I look at the YAML and fix it? There you go. Oh, there you go, right? Oh, wait, why is it saying the reviews? That's wrong. Let's try this. All right. Can you fix the issue with reviews, the service YAML? Yeah, reviews. Reviews in the default namespace. I made a typo. Hopefully it'll figure out that it's default. There's no deployment. All right. Use the service. Maybe you'll have to trust me that it actually goes there and figures it out. Oh, there you go. There you go. It's doing something. It's doing something. Ah, there you go. It fixed it. Let me show you, right? Let me actually, the issue with the review service YAML label selector was been fixed. The selector label was corrected from app reviews to app reviews to ensure the proper pod selection. So if you look at the, since I don't have a lot of time, we'll do the service reviews, YAML. It fixed it, right? It's down there. Thank you very much.